Hi, I'm Will, and welcome to the first episode of Built from Scratch. This is going to be an ongoing series in which we will program from the ground up using the Scratch programming language and programming environment. Starting from a blank Scratch project, we're going to make a game together. We're going to do every little bit of coding on camera, on screen here, and we're going to just go through the process. It should be really fun. It should be really interesting. Hopefully, we'll all learn a little bit about programming, about Scratch, about game design, about game development, and we'll also just have some fun. So, with that said, let's just jump right into it. So, here we are with the blank Scratch project, looking at little Scratch Cat here, and of course the first question we have to answer if we are going to make a video game is, what kind of video game are we going to make? And I have an idea in my head, and I don't want to go too deep into explaining every last thing about my big elaborate game design right now, but suffice to say, in this game we are going to fly a spaceship around. We're going to fly it around the universe, the galaxy, some large collection of stars. We're going to be able to go to different star systems and visit different planets, and some exciting things ideally can happen when we do this. Maybe mining on planets, maybe aliens, who knows? That's a little far ahead at the moment, because for now, for the first little while probably, what we're going to concentrate on almost entirely is getting our Starship, flying it around space, and figuring out what all that means. So, without further ado, let's just do it. So, we're going to fly a Starship. We are not going to fly a Scratch Cat, so I don't need this Scratch Cat. I'm going to right click on Scratch Cat here, hit delete, and I'm going to paint myself a new sprite. I'm going to jump into vector mode. Vector mode, there are two modes in the Scratch image editor. One is bitmap and the other is vector. And they mostly relate to how the data is stored and represented for the computer, but these different representations have real effects that that us humans end up caring about. So the distinctions do matter anyway. Basically, bitmap mode cares about pixels and colors. It considers every image to be made up of a bunch of dots, which is of course how it always ends up on the screen eventually. And so it decides what colors to draw different pixels based on this very straightforward series of colored dots representation. Vector mode is a little more complex because it consists not of points but of lines. It consists of information about shapes. And one of the things that's neat about vector mode is that you can scale shapes up and down and change their size without really changing, without pixelating them or anything else. But one of the things that is nice about Scratch vector mode in Scratch is that you can just use this line tool to make some pretty nice clean lines, and so that's why I'm using it now. So I'm just going to draw myself a little starship here, and I think so. I accidentally Control Z'd out of that. I'm gonna use the line tool, and I'm going to just draw what looks to me to be just a pretty nice little starship. So there we go, like that. I think that's a good little starship. Oh, Scratch does this weird thing with the end caps of the lines, and I have yet to figure out any way to predict what it's going to do, except to just keep doing it over and over again. So, and eventually you get the one you want. I would not say that this is the best way to go about doing this, but it's the way that I have found, and I'm actually having less success with it now. There we go. Oh, really went a little too far back that time, but less success with it now than in general. But all right, well, soon I'm just going to give up and I'm going to call it that's okay. It's not perfect, it's okay. So now I have a spaceship. So now I'm going to go here, I'm going to name it player ship, because sprite 1 is not a very good name for our sprite, and our code will end up being horribly confusing if we leave it as named sprite 1. Now we have a spaceship. I accidentally seem to have drawn it way off center. The center of the costume is over here, and I want it to be, I'm not sure if I want it to be there or in the center. I'm gonna put it in like where the kind of thruster of the starship is. I don't know if that's right or not. It doesn't really matter. I'm gonna go with it for now. We can always play around with it later. So now we have made a starship. Having built this little starship out of 4 lines, we need to fly it around. So how are we going to fly our starship? Well, we're going to fly it with the keyboard. And this is just a control scheme that again, like I've invented, or not invented, I've taken from classic games. Atari is or rather, Atari Asteroids is the game that we're going to most strongly emulate with our controls here. So we are going to have, I'm going to just kind of write this down. We're going to have a control scheme, player controls ship using W, A, S, and D keys, although maybe not the D key. Actually, W slash D, rotate ship. No, sorry. My mistake. A and D, rotate ship, and W fires thruster. My dog may have just barked. It might be a little loud. But A and D rotate, W fires thruster. Great. So, having done that, how are we going to implement these things? Well, we're going to go into events. We're going to make the very basic framework of a Scratch program, and really almost any program that you write, where we're going to have this when green flag clicked, which is our start trigger, and then we're going to have a forever. And this is the stuff that's going to happen over and over and over again in our program, as long as our program is running. The things that we initially, for this purpose, want to have happen over and over and over again are, we want to listen for these key presses, and then we want to move our ship in some way based on those key presses. So to listen for the key presses, we can go over here into control, and we can grab an if statement. We can go to sensing, and we can grab a key pressed block. So we're going to say if key pressed, but we're not going to say space key pressed. We're going to say if key A pressed, then rotate counterclockwise, turn counterclockwise 15 degrees, and if key D pressed, we're going to rotate clockwise, and same basic plan. And then finally, I'm going to duplicate this block again, but we're going to say if key W pressed. If the W key is pressed, we're not going to turn left or right, we are going to move forward. And I'm picking W, A, S, and D here only because when I am writing a Scratch program, I find it easier to be able to control it with my left hand while I use my right hand to use the mouse. You could use the arrow keys here or any other control scheme just fine. So I'm going to press the flag, and now I can kind of zoom this little starship around, and that's pretty fun. I can turn, and I can let go, and I stop, and that isn't what we really want, right? As fun as this kind of control scheme is, as fun as it is to run this little triangle around the screen, it doesn't feel like a spaceship. It feels more, I don't know, it feels like a mouse or something. Like we're running a little mouse around this little cage. And that could be fun, that could be fine. We can make a game where there's cheese and the mouse gets the cheese and avoids the cat and everything else. But that's not the game we came here to make. We didn't come here to run mice around. We came here to fly a starship, and so fly a starship we shall. And so in order to fly this starship, we need it to feel like our starship is in space. And what does it mean to feel like our starship is in space? Well, the main thing is that our ship needs to drift. It needs to move without the thruster. If we stop thrusting, we should keep drifting off in that direction until we apply a different thrust, so that we go in a different direction. So it gives us this feeling of floating through space and having all this inertia and momentum, because space doesn't have anything slowing us down, right? There's no friction slowing us down. So in order to do that, in order to have this inertia, we are going to need to make our key press not control our position directly, which is what we're doing now. Instead of controlling our position, we need to control our speed and then allow our speed to set our position, right? So of course, in order to control our speed, we need to have some way to change it, some way to represent it, some way to think about what our speed is as a number. And so we're going to make some variables. We're going to make two variables. We're going to make velocity x, and we're going to make velocity y. And this, what we're doing here is we are breaking our speed, which is how far we're moving in how far we're moving in some direction. We're breaking it into two components. We're saying there's we're going to break it into how far we're moving in the x direction here, plus how far we're moving in the y direction, right? So, and together, if we do that, both, we're going to end up going in this diagonal line by breaking our x and y, by moving some amount in the x and then some amount in the y, invisibly to the player. At the same time, we will end up moving in this diagonal line. So we're going to have a velocity for our x. We are going to have a velocity for our y, and we're going to need to move based on that velocity. So I'm going to go over here to motion. I'm going to scroll down. I'm going to grab the change x and change y blocks. And instead of changing x and y by 10, which is this constant number and would just result in us always, forever and ever, drifting at a 45-degree angle out into the universe, we're going to change x by velocity x. We're going to change y by velocity y. And while we're here, while we're in this data menu, we're going to remember to set our velocities x and y to 0 when we run our program, because we don't want our velocity to persist from some previous playthrough or something like that. We want to start the ship not moving, unless it turns out we want to start the ship moving, in which case we'll set it to that. But and we also, just for ease of testing, I'm going to grab this go to block, and I'm just going to make it so that we're going to go to 0, 0, right? We're going to always start our thing in the middle of the screen. And now, well, we haven't done anything different, right? I made this velocity x, I made this velocity y, I set them to 0, and I'm changing by 0 every frame, every tick, every time we go through this forever loop. Changing by 0 doesn't do much, so we need some way to make this velocity x and velocity y be positive numbers, or negative numbers, or be numbers that be non-zero numbers, because otherwise, why did we bother? And specifically, we want to change our velocity x and our velocity y when we press the W key, right? When we fire the thruster, instead of moving directly. And we want to change them in some way that has to do with what direction we're facing, right? So if we are facing up, we want to change our y velocity by a lot and not change our x at all. If we're facing to the right, we want to change our x velocity by a lot and not change y at all. If we're facing at a 45-degree angle, we want to change them both by the same amount. And to do this, we're going to need to do some math. I'm going to go back in here to this diagram I was drawing before. We're going to need to do some math where we we're going to think. We're going to be pointing in some direction. Here, let me jump over. It would be the line tool. We're pointing in this direction, right? We're going in this direction, and we want to figure out how much we should go in the x to go in that direction, and how much we should change in the y. And when we do that, what we end up doing is breaking this movement, right? This directional movement into two pieces, and kind of making a triangle out of it, right? We've made ourselves a nice right triangle. We have this as the hypotenuse, we have the x as one of the legs, we have the y as another of the legs, and what breaking out this into a right triangle lets us do is it lets us use the known math of triangles to figure out what figure out how much we want to change each of our velocities by. The math of triangles is called trigonometry, and I don't want to go too deep into it now. I just want to say that there are these two trigonometric functions which you can get using this math block here, and they're sine and cosine, and they describe the relationships between the lengths of the sides of triangles and the angles in them. And look up trigonometry. It's going to be extremely helpful and important to you at some point in your life if you do almost anything involving, certainly involving video games or game design, but also just in general computer programming, engineering, whatever. I use trigonometry a lot, so feel free to look it up. Feel encouraged to look it up. For now, I just want to say we're going to use these functions, and they do the thing I promise they do the thing that we're going to use them for. And we can test it out, and we'll know. So instead of moving 10 steps, we're going to change our velocities by some amount. We're going to change our x velocity, we're going to change our velocity x, and we're going to change our velocity y. And we are going to change our velocity x by the sign of the direction we are facing. The direction, there's this block here called direction, which gives us the angle that we are facing. We're going to change the velocity y by the cosine, I think, unless I'm wrong, in which case, nope, yeah, this is correct. So now, when I press the W key, I fire off in this direction. When I no longer press it, I just stop accelerating, but I keep drifting. So I can turn. I can turn in any direction and face any direction I want, but I don't change where I'm going until I fire the thruster. So this is doing exactly what we want it to do. I'm going to stop. I'm going to get rid of this to-do list because this to-do list is no longer relevant. It is now to done. So this program works. It does almost everything that I wanted it to do. There's one more feature I want to add before wrapping up for now. And then there is one more, the final little bit of cleanup I want to do. The feature I want to add is I want to make it so that we have a little animation, a little simple animation of our thruster turning on when we are firing the thruster, and no thruster at all when it's off. So I'm going to go here. I'm going to go to draw another costume, same as duplicate the first costume, and I'm just going to draw a little bit of spiky fire coming out the back here. So there we go. I'm going to go into scripts, and I'm going to go into looks here, and I'm going to say when the key W is pressed, we're going to switch the costume to thruster on, but we are also going to want to switch the costume back to thruster off in the event that key W is not pressed. How do we do that? How do we do something if something's not true? Well, we can use this if-else statement. I'm just going to swap out the if for an if-else, and I will say if key W is pressed, switch costume to thruster on, change velocity x by sine of direction, change velocity y by cosine of direction. Otherwise, we're simply going to, we're not going to do anything with our velocities because we're not applying the thrust. We're just going to switch our costume back to thruster off. I'm going to throw that here. I'm going to hit go, and we're just going to see how it works. I press W, and I fire the thruster, and now you can really easily see that I only change direction when I move, regardless of whether I'm firing the thruster, but I change direction when I do so. The other thing that this animation just looks nice, but one of the main reasons it's really satisfying and really important for this game is because when we make it so that the thruster doesn't directly change our position, but instead changes our speed, it takes a little bit of control away from the player, right? They no longer directly control where their spaceship is, and that's fun, right? Games are series of puzzles and problems and challenges, so it's good to take control away from the player, but we want the player to feel like they are in control and command of the spaceship, and we want them to feel like when they fire the thruster, something happens. And so having an immediate visual change, a cue that says, yes, you fired the thruster, congratulations, you're such an awesome space captain, is really, really important and powerful. So it also just looks fun. So there we go, we have the thruster. The final thing I want to do is I want to do a tiny bit of cleanup of the code. We have these numbers here, this turn 15 degrees, which is our turning speed, but it's hard coded into our program. So if we want to change it, we have to actually change the code. This means that if we want to change it, we have to change it in two places, and we have to remember to change it in both of them. but it also means that we couldn't change it in game, right? But I want to be able to do that. I want to be able to change it to if I get a better turning jets, or my ship is damaged and we have to repair it. I want the turning speed to go down, or whatever. So I'm going to make the variable to store this bit of data in. I'm going to call it turning speed. I'm going to turn by turning speed instead of turning by 15. But I'm going to go ahead and set turning speed to 15 because, in fact, it turns out that 15 is a pretty decent number. Our program is exactly the same. Doesn't do anything different. It's just a little cleaner, a little easier to work with. Congratulations, us. The other piece of information that I want to be able to modify in game, on the fly, whatever, is our thruster power. At the moment, our thruster power is 1, and we want to be able to change that. So instead of changing our velocity directly by the sine and the cosine, we're going to go ahead and we're going to multiply the sine and the cosine by this variable that we just invented called thruster power. Right, multiplication is the math operation that says if thruster power gets bigger, then the result gets bigger. If it gets smaller, the result gets smaller. So multiplication is where it's at for what we're trying to do here. Again, I'm going to set thruster power to 1 because I think it actually feels pretty reasonable. But I'm just going to check. Look, it turns out this change I did to our program accomplishes absolutely nothing. Our program runs exactly the same as before, which is 100% what we were looking for it to do. Congratulations, us. I'm going to stop, and then I'm just going to test and make sure it actually does something. So now I'm going to set thruster power to 100, and I'm going to go, and oh my gosh, I'm going extremely too fast. Oh my gosh, also I seem to be having internet problems. I'm going to click save now and hope everything works out before the end of the stream. I'm going to set thruster power back to 1 because that was a little ridiculous, and then I'm going to set turning speed to 1, and I'm going to say go, and it turns out, yep, now I have this ship that is just incredibly slow to turn and impossible to control. Great. I'm going to set it back to 15. Thruster power to 1, turning speed to 15. I'm going to go ahead, I'm going to give my program a name since I'm about to share it. I'm going to call it episode 1, flying the spaceship, the Starship. Flying the Starship. I'm going to click share, and I guess I'm going to actually do all that stuff off stream since my internet is having problems right now. So I'll just keep clicking save now and hoping and deal with it later. I'm going to wrap up. Thanks for watching. That was fun. I will next time we'll be exploring what it means to fly around the universe instead of just fly around this little square of space. We're going to answer interesting questions, and we're just going to keep on going until we have a pretty cool game. I hope you will join me. I'm going to save this project. I'm going to share it. It's going to be on my profile, built from scratch with underscores. Feel free to look at it, remix it, do anything you want with it. And feel free, if you have any thoughts, ideas, suggestions, questions, comments, or anything else, just send me a message on Scratch, and I'll try to get back to you. Thanks.